Hello everyone, in this session we will discuss Keras NLP package. Though Keras NLP does not provide exhaustive list of models as being provided by Huggingface, but if you are looking for an alternative of Huggingface, then you can consider Keras NLP package as well. You will get list of the models being provided by Keras NLP package from the given URL as shown on the screen. Let's first talk about Keras NLP modules. These modules serve as a base for any task, rather it's a classification task or a text generation task. As shown on the screen, there are 4 modules such that tokenizer, preprocessor, backbone and task, which can be considered as a classifier or an LLM. You can get more details on what each component does from the given URL as shown on the screen. Let's see these 4 modules in action. Before we start, please note that as of now, Keras NLP does not work with Windows. Also with Python 3.12, it's not working on Fedora and Ubuntu operating systems, though they are Linux. For these to work, you need to use Python 3.11 and Linux system. On my end, I am using Python 3.11 Docker image on Windows operating system. In top right corner, you will get the link of the video which shows how to attach Docker container to VS Code and execute the script. As shown in the script, first we are going to import all the required packages. Here I have used Keras backend as JAX, but you can use other backend as well like TensorFlow or Torch. Based on the selection of the backend, the pre-processing and performance will vary. Here we have set global policy to mixed float 16. It means whenever possible it will use float 16 precision to speed up the process, and in critical operations where accuracy is required, it is going to use float 32. This command will list down all the models and other methods that we can utilize with models class. When we are working with those 4 modules such that tokenizer, preprocessor, backbone and LLM or classifier, we have 3 different ways through which we can call them. This is the very first way. In this way, we are using pre-configured presets such that the configuration or hyperparameters values will be set already for that particular model. We just need to load them and use them. To get the list of the available presets for any model, we can utilize this particular command as highlighted on the screen. Here I have used GPT-2, but you can utilize anything from this particular section. For example, if I want to check presets for Roberta preprocessor, then just replace this GPT-2 preprocessor with Roberta preprocessor and you will get list of presets for Roberta preprocessor. In this method 1, we can define all the 4 components as shown on the screen. As we have seen earlier, LLM preset will contain backbone and preprocessor, hence we don't need to define them. Same way, preprocessor will contain tokenizer, hence we don't need to define them. We can utilize each component separately. Here, whatever model you want to use, just replace GPT-2 with that particular model. For an example, Roberta preprocessor or Roberta casual LM or Roberta tokenizer. This is the method 2. Here instead of providing the model name, we are using task name like tokenizer, preprocessor, backbone or casual LM to just load the preset and using it directly without any further changes. This is the last method, number 3. Here advantage is you can provide your custom configuration such that you can provide custom values of hyperparameters. As you can see on the screen, we are using the model names like GPT-2 casual LM processor, GPT-2 backbone or GPT-2 casual LM, but we are not using from preset method that we have used in earlier 2 methods. Instead, over here we are providing values of some of the hyperparameters as shown on the screen. Also note here that in LLM call, so this is the LLM call. In this LLM call, we are providing backbone and preprocessor, and in preprocessor, we are providing tokenizer, and in tokenizer, we are providing vocabulary. So this is the way through which entire chain of text generation will work. Next, let's see if we run the modules how the outputs will look alike. On running tokenizers, we will get token IDs as shown on the screen based on the data on which model has been trained. Next, when we run preprocessor, it will provide tuple which will contain dictionary of token IDs, padding mask and some other arrays. Here, note that the preprocessor has used tokenizer to provide token IDs. Padding mask has been used to make input sequence of same length. Here, true or let's say 1, it means the token is original and need to be considered by model, and false or 0 means token is padding and need to be ignored by the model. Next, we are going to call backbone, which will provide dense tensors. These tensors are going to be utilized by the given model to generate response via generate method. Finally, we are going to call LLMs, which is going to generate text using its generate method. Please note here that as seen previously, LLM is utilizing all the previous modules like backbone, preprocessor and tokenizer to generate this particular text. And also you can see that based on how we have defined all those modules, the output will be different as you can see on the screen. That's it for the day. Thank you everyone for watching this video.